अभी चेक कर लो. Am I audible now? Right. So you can see now the rank predictor, that is 2026, which is live now. You can check your rank. Right. So you can simply scan this QR code, log into IIT Guwahati website, and click on the responses, copy the URL of your response sheet, and go to the Unacademy rank predictor, paste the URL of your response sheet. Then your rank will be predicted. The most accurate rank you can get here. And we started a new batches. We have started from 24th Feb onwards. We started new batches. There you can see the networks and digitally started. You can find the top educators team of Unacademy. You can find in the single frame में आपको मिलेगा. You do follow these top educators classes to get the maximum benefit to achieve your dream goals. And these are the ESC 2025 rankers from Unacademy. So many rankers are there. And another great feature of Unacademy is Unacademy AI tool, that is UNA. There are three modes are there, that is one is voice mode, quiz mode, and smart summaries. Voice mode, quiz mode, and smart summaries. And the test series which is already live, you can access the test series also. We do offer the two subscription, one is plus wala, the other one is iconic. And so प्लस में आपको क्या चीज मिलेगा? टॉप एडुकेटर्स क्लासेस मिलेगा, लाइव डाउट सॉल्विंग, एवेल्युएटेड मेंस टेस्ट सीरीज, स्ट्रक्चर्ड कोर्सेस, पीडीएफ, लाइव टेस्ट, अनलिमिटेड एक्सेस. इसके साथ आइकॉनिक में फिजिकल नोट्स भी मिलेगा एंड पर्सनल कोच भी मिलेगा आपको. These are the benefits of iconic and plus subscriptions. And you can book your slot according to time convenience. You can communicate with the your mentor. So let's crack it. These are the 2025 rankers from Unacademy. So chalo, let's see one by one problems. And we are going to discuss some important problems we are going to discuss now, and especially from the sequential circuit say. Yeah, take the first problem. The mod number of the counter shown in figure is mod number. First of all, you tell me now what type of counter is it. You tell me now. The moment whenever they given this is, we need to identify what type of counter is it. Whether it is a synchronous counter or asynchronous counter, we need to identify. Yeah, first of all, you tell me now, is it a synchronous or asynchronous counter? Synchronous counter or asynchronous counter, you tell me. And this is asynchronous counter. And this is asynchronous counter, first thing. And thereafter we need to see whether it is an up or down counter. How we can identify up counter or down counter? So here you can see now here clock is given as what element of Q say we have given, and thereafter, and then what type of trigger you see this thing, negative edge trigger. So that's why we have can say minus. So then we'll come it as what element of minus Q. That means अभी ये कौन सा स्टेट में आई? टेल मी नाउ हियर. दिस इज इन द दुख में आई ना. सो द दुख के बाद क्या आएगा? यू टेल मी नाउ. सुख आएगा. So that means this is what counter I can say? This is up counter. So this is up counter. Yeah, you tell me now. So this is the asynchronous up counter. This is asynchronous up counter. Okay. Yeah, you can see this thing here. The clear pin. When the clear pin is active, here they given this is my LSB and here this is my MSB, right? When the clear pin will get activated, you can see the clear pin. Clear. So I can cancel this bubble, this bubble, this bubble, and this bubble I will cancel now. I can treat this as AND gate only now. So when the clear pin will get active, now here the inputs of the AND gate, you see this thing, and that is one is a Q3 and that is Q2, and Q1, Q0 is not connected. So that means what should be now, you tell me. So this is 1 and 1. So since the up counter, so these values are minimum. So that means what we can say, this is nothing but mod number. How much now from this now? This is a mod 12 counter. So from this we can say this as a mod 12 counter, right? Next. Consider the combination of T and D flip-flops connected as shown in the figure. These are connected as shown in the figure. Now they are asking to find initially Q1, Q0 is given as 1, 1. Now they are asking the output Q1, Q0 after 4 clock pulses, what will be the value they are asking. Right. So then we need to find after 4 clock pulses, we need to get the values, right? So let's form a tabular form here. So we are forming this tabular form. Here the first which is given. So D flip-flop and D flip-flop which is connected to what, tell me now, Q1 bar. And the T flip-flop and which is connected to what, tell me now, T0. And we can say this as what, tell me now, Q1 plus and that is Q0 plus. Right. Now, yeah, you can tell me now initial values of the flip-flops are given. Now tell me initial values which is given as what, tell me now, 1 1 given now. So Q1 bar. So this they ask the 4 clock pulses, 1, 2, 3 and let us say 4 clock pulses. We'll see it now. Q1 bar, how much now? 0. Q0 which is equal to what, tell me now, that is 0. So this is 1 now. This is 1. So D flip-flop, if the input is 1, what happen, you tell me now here? Output is also 1. Input is 0, output is also 0. So we'll come it as what, tell me now, 0. T flip-flop, if the input is 1, that is a toggle. Previously 1, so now this is 0 na. Next second clock, you tell me now here. In second clock, D value Q1 bar. Q1 is 0, so this is 1. Q0, so that is 0. 1. So what happens, you tell me now here. Q1 plus, so it will come to be a what, you see this thing, D flip-flop 1. 0 means it is a hold state only. Next, if you have given this thing, right now here, third one, for the third clock, you see this thing here, what this value will come? So Q1 bar, Q1 is 1, so it will become what, I will now 0 na. Q0 is, so 0, so that is 0. So 0 means 0. So this is 0 means that is hold state only na, tell me. Okay. Please explain the first question by making the yeah, fine. So we'll finish this thing. So thereafter we can do it now. Yeah, we'll finish it. We'll finish. Yeah, here in this case, so this value, yes, what is the Q1 bar you tell me now here? So Q1 bar, one given, 1 second, the truth table. Thoda. Here they are asking the order is what element of Q1, Q0. Okay, here they see the output is what element of D flip-flop output is Q0. You see this thing D flip-flop output is given as what element of Q0 is given, isn't it? So D flip-flop output is what element of Q0. That is Q0 plus and this is Q1 plus. Okay. So you tell me now from this now Q1. So initial values are given as what element of 1, 1. So this value 0 and this value 1. 0, then it will become, so what tell me? So that is a 0. So this value 0. Toggle na. So Q1 bar. So 0. So this value 1. Q0 which is equal to 0. 1 means what element of 1. 0 means hold state. Next Q1. So Q1, how much this value here? Q1 bar. So that is 1 and this is 1. 1 means what element of 1? 1 means toggle banega. For the fourth clock pulse, what happens now? Q1 bar. Q1 is 1. So this value 0. Q0 is 1. So tell me now what will come? 0, 1 will come to be a 0. And this value 1 means toggle. So it will become as what? Tell me now. So that is Q1 and this is Q0. This sequence they are asking now. So Q1 value 0, Q0 value also 0. So what's the option you tell me now? C. Right. Yeah, Ashish, if you solve this type of problem in the truth table, so lengthy banega, but lekin you are asking for the truth table method now. So I will do that one. So for this case, we need to frame the table form. We need to form it. So look at now here in this case. Table form we need to prepare it now. Here it is generally it will be a lengthy here. So but try to learn this method. Once you understand this thing, it will become very easy. The truth table method. So this is coffee lengthy banega. Right. So you can see now this is my clock and this is Q3 and this is Q2 and Q1, this is Q0. And thereafter we have seen a CLR, clear pin. When the clear pin will get active, you see this thing CLR, that is given as Q3 and Q2 given, right? Whenever this Q3, Q2, this is 1, it is immediately will get activated. Okay. Now let's see this thing initially. Initially all the flip-flop values are 0, 0, 0. Yes, so here the first clock, when you apply first clock, you see this thing. This is what counter you have seen, you tell me now. Since it is what counter is a up counter, so that means what happens now? Obviously, it will keep on, will get incremented now. Isn't it? These values will keep on, will get incremented, right? So that means first we have given 1. This value will come 0, 0, 0, 1 and clear is active. Next second, so this is 0, 0, 1, 0 banega na. Clear is not active. When this is 1, then only will be active. And third clock pulse 0, 0, 1, 1. This is 0. Like this will keep on, will continue. Let us say 10th clock pulse, what happened? That is 1, 0, 1, 0 banega na. So this is 0. 11th clock pulse, what happens? 1 0 1 1. Clear pin is in a 0 only na. And when you give the 12th clock pulse, what happens now? 1. So this is 1 1 0 0 na. Clear pin active. The moment clear pin is active, so what happened to all the flip-flop values? You tell me now. When you play 13th clock, so then all the flip-flop will be reset karega now. You tell me now. The moment when it is active, so what happens? You see this thing. All the flip-flops reset होगा ना 0 0 0 0 बनेगा, isn't it? Hmm? So that's why this will becomes what? Tell me now. So this is what the states you can find now here. 0 to 11. The states you can find what? Tell me now. 0 to 11. So that means how much you tell me now? The mod number. How many states are there here? 12 states are there, 0 to 11. Next one. A T flip-flop can be implemented by using SR flip-flop. T flip-flop is implemented by using SR flip-flop, which will be the correct sequence they are asking. Correct implementation they are asking here. The correct implementation. So what we need to do here for this one way is what? Tell me now. You need to remember all the conversion tables. That is one way. The other way what we can do here, we can do this elimination of options and solving the problems. Now I need which flip-flop is required now here? T flip-flops. So T flip-flop के लिए what will be the characteristic equation? You tell me now. T flip-flop, the characteristic equation is what? Tell me now. Q plus, it should be equal to what? Tell me now. T XOR with Q. This is the characteristic equation of a T flip-flop, right? Now you can tell me now. So they given SR flip-flop. Let us verify the options now here. I am verifying this option B now here. So you see this thing, S is connected to what? Tell me now here. T into Q bar. And R is connected to what? Tell me now. T into Q. Then from this what I can say now, this is Q plus, which is equal to S plus R bar into Q. So that is Q plus, which is equal to S is equal to TQ bar plus R bar, means TQ whole bar into Q. So that is Q plus, which is equal to TQ bar plus De Morgan's law, that is T bar plus Q bar into Q. So then I will commit as what? Element of Q plus is a, that is TQ bar plus T bar into Q. So this is nothing but what? Tell me. Q plus, which we got it as T XOR Q. This is the characteristic equation of a T flip-flop, right? So from this we can say this is option B is correct now. So, and if you want to do the normally, the only thing is verification of option se hona padega. One by one option we have to verify it. Next one. And see the next problem. And the number of used state in the circuit. Number of used state means what are we now? That is indirectly they are asking the mod number they are asking to find, isn't it? Right. So we need to do the mod number, we need to find out. Let's find this mod number. For this, what type of counter you tell me now? Synchronous or asynchronous counter? So this is a synchronous counter. Same clock now for the both the flip-flops. So we need to form a table form. Yes, first form a table form. Yes, let's form a table form. Here we have the TA and next the given TB. So here this is TA. TA equal to what, tell me? Which is equal to QA QB OR gate. So that is QA plus QB. Next TB equal to what, tell me? TB equal to QB plus QA whole bar. And this is what we can say, tell me now, from this QA plus and this is QB plus. Now you can see now here number of used states we need to do it now here. So initially all the flip-flops are zeros now. So initially 0 0. Let's find out now here TA plus TB, which is equal to what, I'll now 0. And this is 1. So we'll commit as what will be the output. You see this thing here 0 aito 0 hold state 1 toggle. Next this is 1 and this is QB value 1. So this is 1 toggle 1 toggle. So this is 1 and this QB 0 0. This is 1 toggle 0 hold state. Right. Next. So if we see this thing here, whatever the starting state, same state will come back now. So from this, what I can say, this mod number you tell me now, that is a mod 3 counter. So 3 used states are there now. Only 3 states are there. So that is mod 3 counter. Next. In the circuit shown, initially all the flip-flops are reset. The output Q2, Q1, Q0 after 4 clock pulses is. So you can see now, first of all, you can see D flip-flops. Whenever the D flip-flops are there, so what we can do here, this problems will finish with the block diagram se ho jayega. Okay, so we can do analyze with the block diagram itself. So which we can say this as, I am calling this as a Q0 now, this output. So this output which is a Q0 and this is a Q1 and this is Q2. And we have connected a NAND gate, they connected. Okay. So if we form a table form, you can see this is Q0 and this is Q1 and that is Q2. Initially all the flip-flop values will be taken as zeros now. So this value 0 0 0. When you apply first clock, tell me now here the NAND between Q1 and Q2 will come as 1. That 1 will come to here now and the 0 will be shifted here, 0 will shifted here. And when you apply second clock, tell me what happens now here. 0, 0 will come 1. 1 will be shifted, here will come. Next, third clock, you tell me now. We need up to 4 clock. So this is 1, 0 will be 0, 0 complement 1. So 1, this is 1, 1. Next it is 0, this is 1, 1. So they are asking after how many clocks you see this thing. Only they are asking for the 4 clocks only now. So after 4 clocks now this will be the state. They ask us see the order now here Q2, Q1. They are asking in the same order we need to give in. Q2, this is Q1 and this is Q0. Q2 value 1, Q1 value 1, this is 0. So then this is the output. Next one. The figure shows consists of a T flip-flop. Each have clear option as shown in figure. The counter corresponding to this circuit is and what is it? The same thing we do this thing here. First of all, you tell me now. This is what type of counter is it? You tell me now. Synchronous or asynchronous? You tell me now. And here this is asynchronous. Asynchronous. If it is asynchronous counter के लिए what we need you to do here? Asynchronous के लिए what we can do here in this case, we need to identify up or down counter. You see this thing, how to identify up or down counter. So we have the clock is Q and the trigger is given from negative say. So that is minus Q. Minus Q means इसका मतलब this fellow which is in the दुख में आई ना. Yes. This fellow is in दुख. दुख के बाद क्या आएगा हमारा जिंदगी में? सुख मिलेगा. So इसका मतलब this is what counter? Up counter. This is up counter. So if it is now we can say this is up counter. Yeah, you tell me now here from this what I can conclude now. This is a asynchronous up counter. Now clear pin के बारे में देखो इधर. When the clear pin get activated, you tell me now. Clear pin will get active where? So they given. So this bubbles I will cancel it now. This will become under gate only. So now this is my Q2 and this is Q1. Only these are connected, Q0 not connected. Right. Now you can see this thing here. So this value 1, 1 and 0 na. So that means this is the mod 6 up counter. So option D. So this is the mod 6 up counter. Next. Consider the circuit shown. The sequence of QA from the first clock is. The sequence of QA from the first clock they are asking. Now they given JA, KA given. So we need to form a big table here. See the connections now. First of all, you tell me. Right. So here JA equal to what? Tell me. Given to QB. Yes, JA given as QB and KA given as what? Tell me. That is also given as QB only. Next, JB given as what, tell me? QC. And KB given as what, tell me, which is equal to 1. And JC given as QB bar. And KC given as what, tell me now? 1. So this is QA plus QB plus QC plus. So we need the sequence of A sequence we require now, QA sequence. Yeah, initially all the flip-flops are cleared 0, 0, 0. Yeah, you tell me now first clock, now here the values are, this is 0, this is also 0. And 0, this is 1, and 1, and this is 1. So you tell me now 0, 0 means JK flip-flop hold state. 0, 1 reset. 1, 1 is a toggle. Next, QB value 0, 0, 0. QC value 1, 1. QB bar 1, 1. 0, 0 hold state. 1, 1 toggle. 1, 1 toggle. Next, so QB value 1, 1. So QC value 0, this is 1. QB bar 0, this is 1. 1, 1 toggle. 0, 1 reset. 0, 1 reset. And QB, which is equal to 0, 0. And QC value also 0, 0. QB bar, so which is 0 na? Sorry, QB bar, which is 1. This is, and so this is 1. 0, 0 means hold state. 0, 1 reset, and this is toggle. So you can see the option now from this. Can you eliminate the option from this? You see QA. So we have 2 zeros and 2 ones. Only this option contain na? Only this option we have like this na? So this could be the option. Right. A T flip-flop is implemented by using D flip-flop as shown in figure. So they are asking the circuit, what is this logic circuit they are asking to find. They implemented the T flip-flop is implemented by using D flip-flop. Okay. So what should be the logic gate now here? D flip-flop ka characteristic equation we know na? That is what, tell me now? That is equal to T. D flip-flop is D only. And T flip-flop ka characteristic equation is what, tell me now? T XR Q. So that means this gate must be what I can say now here, XR gate. That means this must be a XR gate, isn't it? Next, the frequency of the pulses at the point D in the following circuit is, frequency of the clock signal we need to find. Yeah, first of all, here if I say this frequency is F clock, this given that ring counter, what the mod number of a ring counter is a N. 10-bit ring counter mod number is N only. So 10-bit counter, so that's why what I can say now here, F by 10. And then mod 20 counter. So this means what happens now here, F by, here already we have this input frequencies F by 10. And then again we have this is 20. So this is F by 20. Okay, so it will becomes what, tell me now, F by 200. And the 4-bit parallel counter. Parallel counter means what? Tell me now. Synchronous counter. Synchronous counter 4 bit के लिए mod number is what? Tell me now. 2 power n means 16. So this means what I can say now, f by this is 200 into 16. And Johnson counter mod number 2n. So this means this will becomes f by 200 into 16 into 4 bit, that means 8, 2n. So finally, what will be the frequency of output, you tell me now? So this is f by, so this is 200 into 16 into 8. So how much this value, tell me now? F value how much given now here? 100k. So 100 into 1000 by 200 into 16 into 8. So you can tell me now here. So this value 2. Okay. So this value. So again this value 400. And if we cancel with the 4 now here, 4 2s and 4 1s, 4 2s and 5. So this value we are coming it as 125 by 32. Yeah, how much will come? This value 3.9, isn't it? 125 by 32. So this is 3.9. 3.9. Next one. Consider the below edge triggered JK flip-flop. Present output at Q1, Q0 is given as 0, 0. The output for the next 3 clock pulses is. The output for the next 3 clock pulses they are asking. So here this is a synchronous counter. We need to form a table form. We need to form it now. For the next 3 clock pulses we need to form it. Yes. Here J1. So you can see now. J1 given as what? Tell me now. J1 is connected to Q1, Q0 bar. Q0 bar. And K1 is connected to what? Tell me now here? 1. And this J0 is given as what? Tell me now? 1. And K0 is given as what? You tell me now? That is 0. And which we have this as what? Tell me now? This is Q1 plus, and that is Q0 plus. Okay. And initial state values given now, or the initial state is given, you tell me? Initial state given as 0, 0. So that is 0, 0, initial state. 3 clock pulses we need now. Q0 bar, so this is 1, 1. So 1, 0. Tell me now, 1, 1 is a toggle, 1, 0 is a set. So Q0 bar, so this is 0, this is 1, 1, and this is 0. 0, 1 is what? Tell me now, reset. This is set. Q0 bar. So this is 0, this is 1, 1, 0. This is what? Tell me. So this value 0 and 1. So 3 clock pulses. So we have 1, 1, 0, 1, 0, 1. So this is, I think here in this case, this play counter is locked here only, continuously, 0, 1 only. Even if you apply any number of clocks also, this value will come it as omega 0 only. Yeah, so then recently I have seen this type of problem. So in this counter they asking, after they given this as something 134 clock pulses, what will be the state they asking? After 134 clocks, what is the state now, tell me? Still it is that only 01 only. It is hamesha in that one. So this is 01 में lock हो गया ना. It is always 01 only, isn't it? So then you need to identify the sequence, then we can give the answer easily. Yeah, you tell me now this one. Consider circuit shown in figure. The sum output of a half adder is connected as a clock excitation for Johnson counter. Okay, they given the Johnson counter. Rising edge means positive edge. The output waves at X and Y are shown in figure 2. Okay. Initially, output of the counter is reset to 0. Find the number of state transition at Q1 over the duration time T. They asking to find how many state transitions are there. They asking. Transition states. Nice problem. Yeah, first of all, we need to see this thing as a how many. So this clock of this Johnson counter is what, tell me now? Sum of the output. Now some bit we need to find first of all here. Okay. So yeah, you tell me now this sum KDS sum expression we need. Output or the sum we need now first of all. So here what we should do here, carefully we should do this as a variations. Here this variation. So alag inputs में output is 1 as we know in case of a XOR gate na, XOR gate. Up to 1 clock pulses we need to see how many times sum is 1 here. यहाँ तक. So you can see the things now here initially. So this value 0. In this region output is 1. Okay. Next in this region. So this is 0, 1. So that's why. So then again it will become 0. Again this is 1. Yes, here. Again 0. This is 1 like this. ऐसा continue करेगा check करके बोलिए. So this is the output of the, this is the sum. You see this thing, how many clocks will be there. So here positive trigger 1, 2, 3, 4, 5, 6, 7. 7 clocks are there here. How many clocks are there? 7 clocks are there. And the 7 clocks, those are given to a Johnson counter. I hope all of you know the Johnson counter functioning. Johnson counter functioning, you know now everybody. So this is a 3-bit Johnson counter. So it is connected to what, tell me now, via output which is connected to the input now with a NOT gate. So if I call this is, and this is my Q0, this is my Q1, this is my Q2. So output, and this is the output here, this output of Q2 which is feedback to the input like this. Now let's talk about this thing here. We have clock This is Q0, Q1, this is Q2. Which bit they are talking? Q1, number of state transition for Q1 they are asking. Okay, 7 clocks, 1, 2, 3, 4, 5, 6, 7. Yeah, you can tell me now first one. We can see 1. The initial states are zeros only. Initially zeros only na. So when you apply first clock, will come it as 1, 0, 0. Next 1, 1, 0. Next 1, 1, 1. Next 0, 1, 1. 0, 0, 1. 1, 0, no. 0, 0, 0. Next we will come it as 1, 0, 0. So transitions for the Q1 we need to see now. How many times these changes happened we need to see. How many times there are changes you can find, you tell me. So this value 0, 0, it is changes to 1. It is continued here. Again it is changes to 0, continued here. How many transition? This is one transition, this is other transition now. So totally how many times it is changes, you tell me now here. 2 times this of Q1 value changing. This value changing 0 to 1, 1 to 0. So like we can see control system, you will see the number of sign changes now. Similar to that, we need to see number of times it changes. They are asking the number of state transition they are asking. Okay. They didn't ask the number of clocks. Clocks though 7. But they asked the transition they are asking. So that is what, tell me now? 2. Yeah, right. Yeah, you can see the next one. Initial content shown. Initial content is given as 0, 1, 1. They are asking. So number of clock cycles required to get the same content again. We need to find this mod number, right? Yeah. So try to find out this thing. Now this is my clock. I'm calling this as a Q0. So no, let's call this as a Q3 I'm calling. And this is Q2. This is Q1 and this is Q0. So this is Q3 and Q2, Q1 and this is Q0. Initial state is given as what, tell me now these values, which is given as 0, 1, 1, 1. Let's see one by one here. First clock. So they given XR between what, Q3 and Q0 XR. Q3 and Q0 is XR gate. So will come it as XR is 1. So 1 will come here now. 0 will come here. So this is 1, 1. Next second clock. Yes, 1, 1 XR is what, tell me now? 0. Yes, 1, 0 and this is 1. Next third clock. 1, 0. XR is 1, 0, 1, 0. Next fourth clock. So tell me now 1, 0, which is equal to what? Tell me now 1, 1, 0, 1. Fifth clock 0, 1, 1, 0. Sixth clock 0, 0, 1, 1. Seventh clock 1, 0, 0, 1. Eighth clock 0, 1, 0, 0. Ninth clock 0, 0, 1, 0. 10th clock 0, 0, 0, 1. 11th clock 1, 0, 0, 0. Next 12th clock 1, 1, 0, 0. 13th clock 1, 1, 1, 0. 14th clock 1, 1, 1, 1. 15th clock 0, 1, 1, 1. This is the 15th clock. That's what we have initial state now. So how many clocks required to get back the initial state? Now tell me again. 15 clocks are required. Right. Next one. So frequency. They asking. Tell me the frequency now here. Input clock frequency given as 160 na. Now tell me now here if I call this frequency F ring counter. Ring counter mod number is what? Tell me now n only. So this means F by 10 na. So this is what we can say now F by 10 parallel counter. So that is 10 into 16. Next, what tell me now? F by this is 160 into so mod 25 counter into 25, and this is F by 160 into 25 into Johnson counter 2n. So that means 8. So you tell me now finally output frequency now, output frequency how much will come, which will be given as 160 into 10 cube 1000 by 160 into 25 into 8. So simplify करके आंसर बोलिए क्या आएगा. 160 कैंसिल हो गया. So this 25 4 0 8 5s na here. So this is 5H. That is answer is what? Tell me now. 5. La, 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 la. Next one. Consider the partial implementation of a 3-bit mod 8 up counter as shown below. To complete the circuit, X should be, what will be the X for the while implementation? And this is synchronous counter na. So let's form a table form. T flip-flops. Right, so here we have a T2. Okay, here we should do this implementation. Sorry. Also, we don't want to find this thing here. So implementation is required. Then this thing present state. Next here is a next state and flip-flop input. So here we have a present state and this is a next state and the flip-flop inputs. and present state, which is, so we need to implement the mod 8 up counter. So which we are calling it as, what, tell me now here. So this is, now this is Q2, Q1, and this is Q0. The next state I am calling it as Q2 plus, Q1 plus, and Q0 plus. Flip-flop inputs I can say now T2, T1, and T0. So you can see this thing implementations. Now here mod 8 up counter we should design now. So tell me initially state, if I call 0, 0, 0, next state is 0, 0, 1. 0, 0, 1 is the initial state, 0, 1, 1 is the next state. What? So 1, 1. So this is, next one is 4. If 4 is a present state, next state is 5. Oh, 2 missing, no? Something missing, I am thinking. 2 missing. So this is 1, 0. So this is 0, 1, 0, 2. 0, 1, 0. Then it is 0, 1, 1. So 0, 1, 1. So then it is 1, 0, 0, 4. If 4 is given, next is a 5. If the 5 is given, next is a 6. If the 6 is a present state, next is 7. 7 is a present state, next one is 0, 0, 0. For this, we need to match it. Right. So you can tell me now here. Here we need to find excitation table. Excitation table, you can easily remember for T flip-flop is what, tell me now. Simply XOR gate only. Excitation table. So we have seen now Q plus, which is equal to T XOR with Q. And the T is equal to what, tell me now? Q XOR with Q plus. Okay. XOR gate only. So 0, 0 XOR, which will come to be what, tell me now? 0. We need the T2. Only T2 we should find. 0, 0, 0. 0, 0, 0. 0, 1 is 1. 1, 1, so 0. 1, 1, so 0. 1, 1, so 0. 1, 0, this is 1. So you can see the min terms are here. You can find this is one min term, this is another min term. So finally, what will get the T2 value? Tell me now here. This thing. Q2 bar, Q1, and this is Q0 plus. Okay, next this is Q2 and this is Q1 and this is Q0. So this is T2 equal to what, tell me now, which is Q1 and this is Q0. Okay. Understood. So what's the option? You see this thing here, Q1, Q0. So that is option C. Is this thing clear? Done. Next one. The frequency and the output are the following cascaded circuit is. So you can tell me now, if I say this is the F, now here 10-bit counter, so this is F by ring counter 10. and this is f by 10 into mod 16 means 16 into 10, so that is 160. Johnson counter, so that means f by 160 into Johnson counter to power 2n, so this is 10. So you can tell me now this output which will come to be a so that is 200 into 1000 by 1600. So this value 2 and this is 8. So we can say now 4 twos 250 now. So this value 125. So this value how much will come here? 125. La 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 la. Next one. Consider the sequential circuit shown below. The Z becomes 1 after every n clock cycle. The value of n is. That means indirectly they ask him to find the mod number. Yes. So you see this thing Z, this is the AND gate. So this value, this Z value 1 means this is 1, this is 1, all the inputs are 1. So means this is 1, this is 1, this is 1. Means here it is 0, here it is 0, here it is 0. Then only it will be 1 now. Okay. Now let's analyze in that sense. Okay. This is the flip-flop connections carefully we should do. Here J naught is given K naught, which is both are equal to 1. Okay. Next here J1 is given now. So J1 is connected to Q2 bar. And K1 is connected to 1. And J2 which is connected to, this is Q1. And the K2 connected to 1. Then we have, this is Q0, Q1 and this is Q2. So initially values are 0, 0, 0. Now we need to see when these values again zeros. Okay, after how many clock pulse? We need to see this thing. Right, that is a problem now, tell me. Yeah, you can tell me now. First of all, both are 1, 1. Okay. So this Q2 bar, which is equal to 1, this is 1. So this Q1 is 0, this is 1. So tell me now 1, 1. 1, 1 is a toggle. Toggle, so this is 1. So this 1, 1 is a toggle. And 0, 1, which is what tell me now? That is reset toggle. So again, 1, 1. So here this is 1, this is 1. Next Q2 bar, so this is 1 and this is 1. Q1, this is 1, 1. So this is toggle, toggle, this is toggle. Okay. So the same thing now tell me now, we need to see how many clock pulse will come. We have to see this thing carefully. Okay. So here. So much lengthy will come, no problem. Yes, correct only. We did not connections. You see once everybody. Now first thing. So both are 1 1. Okay. Q2 value 0. So this is 1 1. Q1 is 0. This is 1. 1 1 is a toggle. 1 1 is toggle. 0 1 is reset. So again this is 1 1. Now we can see this thing. Right. Q2 bar, Q2 value 0, Q2 value 0, so this is 1, this is 1, so Q1 is 1, this is 1, so this is toggle, this is toggle, this is also toggle. 1, 1, tell me, Q2 bar, so this Q2 bar, this value which is equal to 0, this is 1, Q1, so this is 0, this is 1. 1 1 is a toggle, 0 1 is a reset, 0 1 is a reset. Next again 1 1 Q2 bar, this bar, so that is 0 bar is 1 1, so Q1 is 0, this is 1. 1 1 is a toggle, 1 1 is a toggle, so this is 0 1 is a reset. Again 1 1, so you can see Q2 bar, so that is 0 bar, that is 1 1. Q1 so is 1 1, so tell me now toggle, this is also toggle, this is also toggle. Next 1 1 and Q2 bar, so this value 0, this is 1 and this is Q1 is 0, this is 1. So tell me now here 1 1 is a toggle, yes, hold state Q1. Yes, this value is what, tell me now? 101. So this value Q1 J2 given as Q1. Yes, we are not getting. Check it, yeah, we are not getting. Connections taken correct only now. J0 K0 is 1. J1 is equal to Q2 bar. Okay, K1 is Q1. J2 is a Q1. K2 is 1. Yes, correct only. Initially 0 0 0. So 0 1 is reset. 0 1 is also okay, reset only now. Yes, correct only. Yeah. So this is here we are getting this thing. So this thing, how many clocks you see this thing? 1, this is 2, 3, 4, 5, 6. How many clocks? 6 clocks. Correct, correct. So here, yeah. Okay, fine. Yes. So this is the mod 6 counter. Fine, that's it for today. So we'll meet in the next class. We'll meet. Next class we'll continue the remaining things. Remaining problems will continue.